Hi, today I want to introduce you to sequences. Sequences of numbers are really functions. So let's do a very quick review of the definition of a function. Suppose A and B are two sets. A function f from A to B is a rule that assigns to each element x of A exactly one element of B denoted by f of x. And this is the notation that you're familiar with. F is a function from A to B. X is an element of A. X is sometimes called the input, and x is assigned this element from B, which is called the f of x, and this f of x is sometimes called the output. And recall that this set A is called the domain of f. So today we will focus on functions where this domain set is in fact either the natural numbers or maybe a subset of the natural numbers of a certain type. So recall that the set of natural numbers refers to this particular set 1, 2, 3, 4 and so on. And we use this letter n for the natural numbers. And I should put a comma here. Also recall that when I write R, it stands for the set of real numbers. So now let's look at an example. Let's look at this example. In this example, A is the name of my function. It's a function from the set of natural numbers to the set of real numbers. And if n is an element of the natural number set, in other words, if n is 1 or 2 or 3 and so on, then we associate with it this number n factorial. That's what this tells you. So if you're looking for a formula for the function, we can think of this as a of n equals n factorial. And remember, the inputs into the function come from the set, so the inputs can only be 1 or 2 or 3 or 4 and so on. And we know how to calculate the factorial of each of those numbers. So now we wanted to take this example of a function, and we want to write it in a slightly different way and then call it a sequence. And the sequence is still this function, but we'll just have new vocabulary for the same object. So here I've written out, I've actually computed A for 1, 2, 3, and you can compute it for the rest of them. A of 1 is 1 factorial, A of 2 is 2 factorial, A of 3 is 3 factorial, and so on. Now let's say we collect these outputs in order. So I start with 1 factorial and then 2 factorial and 3 factorial. I don't skip any of them. I collect them in order and I write them in this manner, in this sequential manner. That would give me what we call an infinite sequence in this manner. And this is really same as 1 factorial is really the A of 1 that I took. 2 factorial is really the A of 2. There is my A of 2 and so on. And in general, the nth element of the sequence, how do we get it? We input n into the function, and whatever output we get, that is what is our nth element of the sequence. Now, next thing we do is we really look at A of 1, A of 2, A of n, and this parentheses notation and all of that, and we ask ourselves, can we devise a less cumbersome notation? And that gives rise to this notation. Instead of A of 1, we choose to write it as A subscript 1. So that A subscript 1 is really a shorthand notation for this A of 1. So, so here are the new ways of writing the same old thing. A of 1, A of 2, dot 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 A of n. Now I'm writing it with the subscript notation. A sub 1, A sub 2, and so on. And then that means A of n equals n factorial. That can be thought of as A sub n equals n factorial. Same concept, slightly different language. And once we convert it into this language, instead of talking about the function A of n equals n factorial, oftentimes we say the sequence, and we use this notation, curly braces, A sub n instead of the A of n, and then we write what the formula is, where A of n equals n factorial, instead of writing it this way. And so, and remember, this sequence is an infinite sequence. When nothing is stated about n starts with 1. So A of 1, the first element of the sequence, is 1 factorial. Next, 2, A of 2 is 2 factorial. And we continue on. That's how we get this particular sequence. So in this example, the domain is the set of natural numbers. Let's look at an example where the domain is a subset of the natural numbers. Here are some more examples of sequences. Here I've used the sequence notations, the curly braces, the same notation that we use for sets, because in fact our sequences are infinite ordered list of elements or infinite ordered sets. So in any case, here I use that and I say where a sub n is n minus 5 factorial, and I put a restriction on n. So here n is greater than or equal to 5. So that means this the inputs into this function are not every element of the natural numbers, but they're only they start at 5, 5, 6, 7, 8 and so on. And you see why I have done that. If I put anything less than 5, I would get a negative number and whose factorial is not defined. So here if I put n equals 5, then I get, that's how I get my very first element, and that is my 0 factorial. And for the second element, I put the next natural number in the list, and n equals 6, then I get my 1 factorial, and that's how I get the elements of my sequence. So now here's another example. Here I don't use a sub n, I simply put the curly braces and I put the formula for elements of the sequence. And here remember the letter n as opposed to x or y. This letter n reminds us that it's an element of the natural number. So if I don't tell you anything about n, such as n greater than or equal to 5 or anything like that, then simply assume n starts at 1. So then if you put in 1, n equals 1, I get the first element of the sequence. If you put in n equals 2, I get the second element of the sequence, and so on. So this sequence expanded out is exactly this sequence. And remember, the order is important, and this is an infinite sequence. Sometimes we don't say the word infinite, we just say sequence, and the interesting sequences are really the ones that have an infinite number of elements in them. And here's another sequence, negative 1 to the n. So if you put n equals 1, then you get negative 1. That's your first element of the sequence. Put n equals 2, negative 1 quantity squared, that's 1, and that's your second element of the sequence, and that's how you get elements of your sequence. Now remember, we can also talk about sequences where we cannot give a very specific formula for the nth term, formula like this one, or like this one, or like this one. Still we can use words to describe what the nth element of the sequence is, a very precise way of saying what the nth element of the sequence is. So here I have a sequence p sub n, where I tell you that p sub n is the nth prime number. So if I start writing them out, then I know 2 is the first prime number, that's the smallest number, prime number. Next one is 3, next one is 5, next one is 7. I could probably write down the prime numbers under 100, or maybe if you give me more time, under 200, but we do not have a formula for the nth prime number. So I can also talk about such sequences where I cannot actually write any formula for p sub n. And we will discuss limits of sequences only in an intuitive and informal way in the next video. Thank you.